All right, so let's go ahead and take a look at our second practice AWP here. So definitely along the same lines, we still have a box that we're making, or a rectangular prism, um, and we're still trying to maximize that volume. This is actually similar to that bonus problem we did the day before spring break, where you guys had pieces of paper and we're trying to figure out how big to cut out of those corners in order to make the largest volume. Okay, so you guys had to do some guessing and checking, but we now with the graphing calculator know we can figure it out exactly. Okay, so just like the last one here, I'm going to kind of go through the steps in solving this, and then talking about what I would make sure I included in my final write-up. So since I'm looking for volume, I definitely am going to need to start with a volume equation. So I know volume is length times width times height. So here what I have to think about is when I cut out these pieces, so this piece would be gone and the sides would fold up, the height of my box is just going to be X. It's going to be however much I cut off. Okay, if I think about the length of my paper, then the length was 30, but since I'm cutting some of these ends off, it's now going to be 30 minus however much I cut off twice, because I'm cutting from each end. So 30 minus 2x. And then the same for the width here. So the width started at 20, but I am cutting off 2 pieces that are size x. So that would be my volume equation. All right, from there then, we would go over to the graphing calculator, and I already typed the equation in. And I want to think about the window here. So I want to think about what is the maximum amount I could cut off to where it would make sense, or the minimum as well. So technically I couldn't cut off 0. I could do just above 0 though. And then if I think back to my picture here, if I start at 20 and I cut off 1 inch from each side, I would be at 18. If I cut off 2 from each side, I would be at 16. That would work all the way up until 10, because if I cut 10 from each side, I would have my entire length there of 20. So I'm going to say my max is 10, because I could not do 10 or above. All right, so the y's, then that's my volume, and I have no idea what the volume of this is going to be, so I'm just going to graph with what we already had in there. So it looks like it shoots up super duper fast. We're just waiting for it to come back down. So I need to be able to see way higher. It's got to be way up there. So I'm going to go to like, oops, I don't know, 500, because it looks like we were way off there. So a little better, but we still have a ways to go. I'm going to try another 500 or so. Let's try 1,000. And it looks like we've almost got that maximum there. So I'm just going to do a couple more hundred, maybe try like 1,200 or so. And there it is. So again, the volume is just kind of a guessing and checking game, because we don't really know what it's going to be. All right, so I want to calculate that max. So doing my left bound and my right bound. Okay, so my maximum is 3.924 and 1,056.306. So I want to include that here. So my max. And notice I'm using 3 decimal places here. Okay, so I've got my volume and my max. So those were the 2 things they talk about. So how large should the cut be? So what I want to make sure I realize is that I'm answering this with that maximum. This is how big the cut is going to be. And this is how big that volume is going to be then. So I've got everything I need to answer those first 2 questions. I now have to look at the final dimensions of the box. So I know that for the dimensions, I'm just looking at this volume equation and plugging in this x value that we got. So when I plug in x here, that's just my first dimension is 3.924. 3.924, and this is in inches by, if I plug in 3.924 for x in this 30 minus 2x piece, then I get 22.152 inches. And then my last dimension would be the 20 minus 2x, where I get 12.152 inches. All right, so there's all the pieces they were looking for us to answer. So we've now solved for all of them. So we just kind of have to make our final write-up here. So again, I'm just going to do things we want to make sure we include. So it's similar because the problems are very similar. We just have to address that idea of that x being the cut versus one of the lengths, like it was in the last rectangular prism. Okay, so in my write-up, I want to talk about how I set up the volume. I want to set up that I found the max because, and that's where you would fill it in. Why did I need to find that maximum? And also, what does the max represent? Ooh, there we go. Okay, so then again, we have to talk about claim, evidence, and reasoning. So making sure in our write-up we're hitting on all of these things. So my first claim is that a cut is going to be 3.924 inches. That's one of my claims. Another claim is that the volume is 1,056.306 cubic inches. Okay, notice I'm using proper units here. And my last claim is that the dimensions are, and I'm not going to repeat them, they're right up here. All right, so there's our claim. Evidence, so what did I need to use to get that claim? I needed to use that volume equation. And I also needed to use the maximum. Reasoning then, so how did I know what to do? Okay, so things you want to make sure you hit on here. So specifically, why 2x? So when I was writing this value equation, why did I have to subtract 2x? So make sure we're talking about how we started at 30, but when we cut to make that height of the box, we have to cut from both of those ends. Okay, same for the 20 as well. Other pieces of reasoning is that the max is the largest volume, so the maximum of that polynomial is going to give us the largest value. That's why we wanted to find the max. So that's why we wanted to find the max. The evidence is the actual max, and the claim is using that maximum to get the cut and the volume piece of it. All right, and those definitely lead right into the dimensions then as well, since they follow directly from that cut length. So go back, look at your outline that you wrote, see if you hit on these things. Remember, the hardest one to get is the reasoning. So make sure you're really read carefully to make sure you're hitting that reasoning piece in there. If you've got time left, this would be a good idea to actually practice writing out your AWP. Make sure you're doing things like including units. Make sure you're using mathematical terms in your writing. Make sure you're using paragraphs and punctuation. Make sure there's flow. Yeah, so this will definitely, this second one especially, is more similar to what you can expect to see on Monday. It's very, very similar to this problem. So definitely make sure you're familiarizing yourself with this problem over the weekend. See you guys Monday.